Okay, so in the last problem, we were able to compute the L and U factors of the coefficient matrix. So once these two matrices are known, or once the coefficient matrix has been decomposed or factorized into L and U, we can now solve the system of linear equation using LU decomposition. So the first thing that we have to do is employ forward substitution to solve for vector y in the matrix equation. L times y is equal to b. Okay, so that's the first step. So L is known. This is obtained from either Doolittle or Kraut's method. And then by forward substitution, let's solve for y1, y2, y3, and y4. When we say forward substitution, we start with the first row, solving for y1, and then we end in the lowermost row, solving for the last unknown. Okay, so we have y1 is equal to 2 because 1 times y1 is equal to 2. Okay, next, using y1 is equal to 2, we can now solve for y2, which is 4 times y1, where y1 is equal to 2, plus 1 times y2 is equal to 3. So solving for y2, we have equal to negative y2 is equal to negative 5. Next, let's proceed to the third row. So we have 2 times y1 plus 8 over 13 times y2 plus 1 times y3 is equal to negative 3. And solving for y3, we have negative 51 over 13. And lastly, let's solve for y sub 4. So we have y sub 4 is equal to negative 2. Once all the elements of y vector is known, we can now go to the next step, which is using backward substitution to solve for what is unknown in the system of linear equation. Because ito naman talaga yung gusto natin i-solve, di ba? Yung unknown vector or vector of unknowns. So by backward substitution, we will use u times x is equal to y. Okay, so that we will start at the lowermost row going up to solve for the unknowns. So from the lowermost row, we have negative 2/3 of z, which is equal to negative 2. Therefore, z is equal to 3. Okay. Next, let's go to the third row. So negative 36 over 13 of y plus negative 29 over 13 of z, where z is equal to 3. So let's solve for y. Y is equal to negative 1. For the second row, we have 13x minus 15y plus 2 times z is equal to negative 5. So let's solve for x. So x is equal to negative 2. And then lastly, let's solve for w with known values of x, y, and z using the first row of the matrix equation. So w is equal to 1. So that's it. That's how you compute for the solution to the system of linear equation using LU factors.